Hello. It seems that we are online. Could you please tell me if you can see and hear me well? We have good connection. I see no data loss. Should be fine. I will write in our live streaming channel. Let's take a look. What do we have there? Yeah, it works. Okay. Anyway, we can proceed with discussion of your final task. You had to implement two assignments. One of them related to error handling and login, and one of them is related to authentication and authorization. Let's take a look at what has been done. First of all, you had to implement authentication and authorization using JSON Web Tokens. You could implement solution with one token, or for extra point, you could implement solution with refresh token as well. So you had to implement sign up endpoint, login endpoint, and refresh endpoint. Sign up allows you to create user using login and password, and login allows you to receive access and refresh token if you implemented refresh tokens, and refresh allows you to get a new pair of tokens using refresh token. And you have all these statuses mentioned in assignment, how your endpoint should work. Also, sign up should store password as hash, and you could use bcrypt or bcrypt.js for password encryption, and you shouldn't store raw password in database. In case you need to compare password, you need to compare password provided by user with hash that you store in database. Also, your JSON Web Token access token should contain user ID and login in payload, and should have expiration time. Also, it should be less than expiration time of refresh token, of course. And also, your GVT access token should be added in authorization header, and all requests to your REST entities should be covered by this authorization. Also, if header is missing, or it doesn't follow bearer scheme, or something else is wrong with access token, you should return unauthorized status code, and your secrets should be stored in .env file. This is what you had to implement according to the assignment. And also, you have some scoring for implementation of endpoints, for storing user password in database as hash, for implementation of access token, for covering all the endpoints with authentication, and also that you separated this logic into extra module within application scope, of course. And also, as advanced score, you got score for refresh implementation. This assignment is mostly about tests, because you need to run tests with this script, test aus, and for each failing test you have forfeits in 10 points of score. Okay, that's basically it. Let's take a look at the code. Unfortunately, I have no Docker on this machine, so I will not be able to run this application. But anyway, I think we are mostly interested in code because, of course, during review you will be able to run solution of other students and you know how to test it functionally. Okay, as we are looking at authorization module, let's begin from it. First of all, we have this module in API folder, we have aus folder, and we have module here. As far as we can see, student used Nest.js JWT library, which provides you a very handy way to work with JSON Web Tokens and Nest.js together. And just as always, you only need to use this stuff in module to provide all the necessary stuff using dependency injection. By the way, we use this system constant upguard. Do you know what it means? Please write to the chat if we have someone online at the moment. Not sure you will be able. Okay, you will take a look at the record in this case. This system constant is provided by Nest.js for dependency injection of guard. Specifically, we use it for dependency injection of aus guard to be able to use it. Also, we have good documentation for this JSON Web Token module. It's mentioned in docs Nest.js. As far as I remember, this is in security, authentication. Yeah, and we have a good example how to configure this module. Yeah. And we have this information. We have here information how to implement authentication guard, how to enable authentication, how to integrate with well-known solutions like Passport. So, by the way, Nest.js Password is also available for you, so you don't need to write a lot of boilerplate. You don't need to write your own modules. You only need to reuse existing solution. So if you want to implement authentication and authorization using Nest.js, you have very good examples in documentation, just as always. Nest.js documentation is awesome. Okay, so here we provide default token expiration time, which is taken from process env token expire time variable. Also, we get secret from process env. It means that we store it in .env file, and we register it as global, which is also useful for us. Let's take a look at the controller. We have controller for aus endpoint. We have this method login, which uses authentication service login method. In case if we get some error, we log this error and throw forbidden exception, which will return corresponding code. What else do we have here? We have sign up method here, which handles request to aus sign up with post method, and also it calls corresponding aus service method and throws conflicting error in case of if user creation failed. Also, we have this controller for refresh. It's pretty same. it takes a refresh token from body. You can see this body decorator that is applied to the data transfer object, and it calls corresponding service method. Okay, what else do we have here? In general, looks fine, but first of all, we don't need this HTTP code decorator because Nest.js does this work for us. It returns OK by default. So you need to specify HTTP code decorator only if you want default OK code to be different from 200. So you should apply this decorator on other methods, but it's useless because it will not change anything, or better to remove here. Also, I see a small mismatch between how this argument named and type. It's signing DTO, but type is named login user DTO. So it would be better to be more consistent and have the same naming here to avoid some mismatch. Also, as far as I can see, this throws similar errors, so probably we could avoid usage of multiple if statements. It could be one statement because we can check that error is instance of forbidden operation error or user not found error. And by the way, we could probably extract this logic into some function because anyway, if error is bad token error or forbidden operation error or user not found error, it results in forbidden exception. So this function could check error and we could avoid this duplication here. Also, we can see that we have this public decorator here. Generally, you have like two options for protection of your endpoints with public protection of your endpoints. You can mark protected endpoints with some private decorator, or you can make this make all endpoints protected by default and only mark public endpoints with some decorator like this one. And as for me, I prefer a second option because of course it's more secure. We don't have to think about marking endpoints as protected. We can just mark explicitly mark public endpoints as public, and that's it. So it helps us to avoid situations when we can forget to mark some endpoint and protected, and it will be exposed to everyone. Broken access control, OWASP top 10, you know that. So this approach looks good. Okay, let's take a look at the public decorator, what it does. It simply sets Nest.js metadata and it sets public key. We will take a look at how it is used later. Okay, cool. So we can see that just as usual, our controller handles request, provides call to the corresponding service using dependency injection, and it just returns response depending on how service worked. So looks correct. Okay, let's take a look at this service. We use this forward ref stuff to avoid circular dependencies. We already seen this specifically for favorites module. Also, what we do for login, we search for user, we compare stored password with which is hash with provided actual password by user, and if it's not valid, we throw forbidden operation error. Otherwise, we create tokens using user ID and login in payload according to the assignment. And generate tokens simply does this kind of things. It only generates access token using GVT service. GVT service is provided to us with Node.js GVT. That's why we like it so much. We only need to use this service using dependency injection and use its methods. And also we explicitly set expiration time for refresh token here. I remind you that we've set expiration time for the default expiration time using GVT module register, but here we set a different expiration time for refresh token. Okay, what do we have in signup? It's simply alias for creation of users, so we used the user service, which creates user and returns created user. If it failed, we throw user creation error. By the way, I wanted to say that probably we could throw error if something unexpected happened, but for sign up it doesn't matter for us. So if any error happened, we can just throw user creates an error. What do we have in refresh? If refresh token was not provided, we throw unauthorized. Otherwise, we try to verify provided token with the same key that it was issued with. And if it was successful, we simply generate tokens and return it. Also, we check login from refresh token. By the way, I'm not sure we really need to this part, because if token is valid, we assume that identity that provided to us this token has right to do some stuff in our application. So if we will just check login and so on, or password, we don't need tokens in this case. So probably this check is like excessive. But maybe if we don't have this user anymore, and for example, this is our requirements from business logic, we don't want to refresh, we don't want to grant access to users that no longer exist but has valid refresh token. This also may be okay. Maybe it's even more secure, but it was not required to our application logic. I have one minor suggestion. I would like to cover probably whole code with try catch block and check error inside of catch block, inside of this multiple throwing errors and so on, because you have multiple places where you throw errors. Probably it would be better to put everything in try block, throw errors, and in catch block you can check what error do you have and what you need to do with this. It's better to have like one place where we handle error, because it will be easy to maintain and debug and it's less buggy. Okay, we've seen how our authentication works. Let's see how guard is implemented. Guards allows us to terminate request. So our guard implements can activate interface. We have to implement this can activate method here, and it's used to control access to some specific routes and operations within your Node.js application. What do we have here? We have this constructor, of course, that is used to get services provided by dependency injection. And we have this canActivate method. First of all, we use reflector to get this public key from metadata. I remind you that we set this key by public decorator. Also, if this is true, we consider that endpoint is public and we return true, which means that we can proceed with our request. If endpoint is not public, we need to switch context to get request, and this is by default express request, which is running under the hood of the nest. And also we extract token from request headers, specifically from authorization header. If we have no token, we provide unauthorized exception. Otherwise, we try to verify our token using our JVT secret key. Then we try to find this user, check that we still have this user. Not sure, by the way, that we need it here, because we already checked this on login. But okay, probably user our user does not exist while we while token is not expired. But for me, this looks like overkill, and as I already mentioned, going to performing request to database every time you verify something, it kills idea of tokens. Okay, if login doesn't match, we throw bad token error. Otherwise, we set user ID and login to request, and we return true in this case. Okay, and if any, and we have this private method extract token from header, which simply takes authorization header, splits it by white space to separate bearer part and token part. And if first part is bearer, then it returns token. Otherwise, it returns undefined. Where do we use this auth guard? We connect it to using auth module, and it works globally for all controllers, because we connect this module to our application. What else do we have here? We have this refresh tokens DTO. We have this login user DTO. We have this decorator that we took a look at, and we have interface for payload. Probably that's it regarding authorization. Do you have any questions? For post, I think it returns 201. Yeah, Sergey, you are right. My bad. Yes. It was necessary to cover task requirements. Why not promise all? Probably we could take... yeah, probably we could perform those asynchronous calls if we need all of them, and if any of them fails, we return not successful result. Probably we could use promise all and do it in parallel, right? Okay, that's it for authorization. Let's take a look at logger implementation. and exception filtering. So we have this exception filter here. It implements exception filter interface, which is provided by Nest.js core package. According to the specification, it implements catch method. What it does? First of all, we have this catch decorator, which do all the magic. By the way, we didn't have this decorator here because this is just like interface, but to make this class exception filter, we need to apply a specific decorator here. We should not forget about it. Okay, what this catch method does? It just called when some exception is thrown in the application during processing of HTTP request. It receives two parameters: exception, of course, itself, its exception that was thrown, and host. It's arguments host that provides access to the like current execution context. Also, we are logging our exception. After that, we get HTTP context and check. If our exception is HTTP exception, we extract status from it. Or if we have unknown exception, we set internal server error status. And we form response body, which includes status code, which has pass and from HTTP request context, and which contains a message. If it's HTTP exception message, we take message of exception itself, or it's internal server error, or if it's not HTTP exception, we set as message that it's unknown error. Better to do it like this. Okay, this looks pretty simple. And this is our by the way, we respond from here. We use HTTP adapter reply, which is used to send a response to the client, and it takes a response object from our HTTP context. This is like by default again express response object, and determined status code and response bodies that we formed here. In general, this is like a central place for handling exceptions that occur during processing of our request. It logs error, checks, determines correct status code and the response body, and sends error back to the client. Okay, how do we use this filter? We use this exception filter globally. We connect it to our application using app use global filters and provide it here. Okay, let's take a look at Logger. This code defines middleware that is used for logging. First of all, let's take a look. We'll check because someone can pass 0 login level. Okay. First of all, we take one parameter config service, and we determine login level from environment variable log file login level. Also, we determine log file size, and we create files for login using this data. And we create two separated files for logs and errors. I think in general it's okay, but probably it's not a good option to create this files every time on creation of new instance of login service. This can be problematic because we can call this, we can create instances of this class multiple times on dependency injection. Specifically, if you have like multi applications that have some shared stuff, and probably it would be better to make these things explicitly. Okay. What else do we have here? We have all these methods that checks log level inside and uses methods from logins from console logger of Nest.js using super keyword. And it creates formatted message and logs this to corresponding file. Probably I would like to extract this logic to some like more generic method. Probably we could have some like log to file method. And have some check here, like if this okay. Check that we need this log at all, for example, and if we need it, we could just use like we need level. In addition, we could just use something like this. And we could create this formatted string here as well. And we could just use this log to file or log to error, because it looks pretty same. All these methods looks pretty same. It calls corresponding super method with message. After that it creates formatted message, and after that it writes to file. So we could probably make this method shorter. Okay. What else do we have here? We have check file for normal logs. We have this check for error files. We see that if it has file size that is bigger than allowed, we set specific flag that we need to create new file. This is to ensure that we have log citation. In general, looks okay, but once again, here we have too much. Here we have this inline logic. Probably I would extract this into variable, and these methods are pretty same. So once again, it could be one method that just check different files. And log to file, we get pass, we check that file exists. If we need to create new file with logs, we create new file, and after that we write logs to file. If something goes wrong, we just log this error. And after that we set should create new file log to false. And pretty same to the error login. Only one difference that we log error stack for some reason. Okay. In general, in general, I have concerns regarding duplication. It has a lot of it. I have concerns regarding this synchronous operation, because synchronous operation can block event loop, and anyway, this creation of writing to file system in constructor of injectable service, it has like downsides, because it may affect performance, and also constructors are executed every time when injectable service is created. So multiple instances of this service can have conflicts. And that's basically it. Let's take a look at Logger middleware. This is just middleware that implements corresponding interface. It's injectable. It contains corresponding decorator. What else do we have here? We can see that we extract base URL, body, and params from request. And also on finish of request, we log status code using our login service. And when we are good to go with this request, we can call next. That will pass request to the next middleware, if it exists. Once again, looks pretty simple. Okay, this middleware is used inside of the app module using middleware consumer on the top level of application. And it's applied for all roles because we have this asterisk here, which means everything. That's basically it. Do you have any questions? It's showtime, ladies and gentlemen. Isn't it better to use write streams like this? I like this easy access to file size via bytes written and continuous writing. You can use write streams, but probably to append a small message to existing file, this is just like overkill, because you need to recreate all those instances of write streams all the time. And probably there is not so many sense in this for this specific case. But of course, if you have to write bigger logs, or if you need to do it real time, something like this, it would be nice to create those streams. By the way, you don't need to recreate it. You can just use open streams, because this is just an interface. It should not always work in flowing mode, and it can be okay. Okay, let's wait like 3 minutes, and let's finish with this one. Maybe we missed something. Is nullable decorator, all exception filters. We have a lot of errors here. Okay, custom errors are fine. TTO guards. What else do we have here? We have handling for uncaught exception and unhandled rejection according to the task description. And it's applied using process on method. Also okay. Any suggestion where to find work or internship? Unfortunately, I have no suggestions for you at the moment. You should just create your CV and like send it to multiple companies, and you will, when you will get response, you will be able to pass technical interview and find a job. I spent so much time for describing PR. To be honest, yes, you had like many information in pull request. It's okay. Yeah, it's always good to provide some information. Okay. Yeah, it's very useful. It's nice. And it's especially good taking into account that I am not able to run this application on this machine, but I ran it on different machine and all tests are passed. So this works fine. By the way, you can put information like this in README as well, because it's useful for people who will be running your application, and probably it's easier to find information there than in your pull request. Or you can put it in pull request and in README. It's also nice. Okay, so that's it for our course. Soon you will be able to share feedback to the school. I will share with you one more form what could be improved on this course. Thank you for participation. I wish you good luck in searching your work or in applying your acquired skills in your project if you already have one. So it was a pleasure for me to work with you and to run this course. Thanks again and have a nice evening. Bye.